ขอบคุณค่ะ and good afternoon from Thailand to everyone who joining this webinar. Welcome to CESRA Talk on PhosAgro solution to current environmental issues and climate change. And our speaker is already with us. Today's discussion will focus on PhosAgro's roles in addressing environmental and agriculture challenges as a leading global producer of mineral fertilizer. PhosAgro promote sustainable fertilizer practices that enhance soil health and actively contribute to UN initiatives supporting the Sustainable Development Goals. And our speaker will provide further insight into the company works and initiatives. And it is our great pleasure to have with us Dr. Vladimir Nosov. He is a head of the Competence Center from PhosAgro, and he finished his PhD in soil science from Lomonosov, Moscow State University of Russia. And he started his career as scientific officer at the Agricultural Research Station in Moscow regions. Later worked in the International Potash Institute and the International Plant Nutrition Institutions. In 2019, Mr. Vladimir joined PhosAgro and became the head of the Competence Center located in Moscow with a number of publications, research papers, proceedings, conference and review paper publications. He is authors and co-author of more than 120 publications on soil fertility and plant nutrition. Dr. Vladimir, thank you very much for joining us today. And we are honored to have you with us. And I will now hand over the floor for your presentations. And following that, we are going to open the floor for the questions and the group discussion later. If you are ready, the floor is yours.
Thank you so much for the introduction. Good time of the day to all the participants of our today webinar. Good morning from Moscow. It's morning time in Moscow. And first of all, I would like to say many thanks to organizers, to CESRA, for inviting me to our today meeting to such an important webinar. It's my great pleasure to speak about PhosAgro solutions to current environmental issues and climate change. Let me share my presentation now. Just I would like to switch to the full screen. Is it okay? So I would like to speak a few words about PhosAgro company. PhosAgro is a vertically integrated Russian company and one of the world's leading phosphate fertilizer producers. Our environmental safe products help farmers from more than 100 countries through the world to improve crop yields and, of course, to improve crop quality. PhosAgro, importantly to note, produces more than 50 grades of phosphate fertilizers, ammonia and feed phosphates, along with high-grade phosphate rock. In PhosAgro company, I'm the head of the Competence Center. Moreover, I am a deputy head chair on agri-technologies of the working group on agribusiness of the BRICS Business Council. On my educational background, I am a soil scientist, so I'll discuss in more details issues related to soil health and to plant nutrition. You know that there is quite a large number of current environmental and climate challenges, including improving nutrient use efficiency, decreasing soil nutrient losses to aquatic ecosystems. And here is an example of Baltic Sea eutrophication. Of course, both nutrient losses and global warming negatively affect the situation. Other important issues are related to mitigating atmospheric nitrogen losses and greenhouse gas emission from our soils. Also increasing soil carbon sequestration, soil health improvement, rehabilitation of degraded soils through higher availability of nutrients and greater soil biodiversity. And it's important to mention the reducing heavy metal inputs with phosphate fertilizers to agricultural soils to decrease soil pollution. PhosAgro is the world's leading phosphate fertilizer producer, and we have a number of effective solutions to address the above mentioned challenges. These important solutions include optimization of nutrient management, I mean source, rate, time, and fertilizer placement too. Second, production of low cadmium phosphate fertilizers, reclamation and amelioration of soils, alkali soils, first of all, using our products. And yet one issue I would like to mention, it's related to a silicone-containing biostimulant used for seed treatment and for foliar application during crop development and growth. So let me start from the first chapter, from the optimization of nutrient management, including source, rate, time, and fertilizer placement method. You know that balanced application of nutrients, including phosphorus, a macronutrient, is a key component of crop production and crop quality. I would like just to cite the results obtained in the long-term field experiment in irrigated maize. As you may realize, according to the last column in the presented figure, nitrogen and phosphorus interaction in maize gave a much higher grain yield compared to an abstract sum of yield increases due to the application of straight only nitrogen and phosphorus fertilizers. And this abstract sum is plotted in the third column. And of course, the interaction of nitrogen and phosphorus gave the best result. It's importantly to indicate that soil potassium level was quite high in this experiment, so potash fertilizers were not applied. The objective of a two-season study conducted in a partnership with the University of Belgrade in Serbia was to adjust nutrient management practices for maize, for grain maize grown on Chernozem soil. It's a calcareous soil, as you know. Field experiment in this case included 6 fertilizer treatments. Importantly to note that the initial soil available phosphorus was very low. Available potassium was in the medium to high ranges, and available sulfur was low because of low organic matter content. Farmers' nitrogen application practice, the first treatment, was found to be excessive. It's the first columns. While phosphorus application practice was found to be insufficient. Just let me indicate, farmer applied 150 kilograms of nitrogen and about 60 kilograms of phosphorus, P2O5 per hectare. So nitrogen was excessive, but phosphorus was insufficient. We found that phosphorus application up to 80 kilograms per hectare was optimal in this environment. Sulfur application improved grain yield, improved quality in higher yield conditions in the season with optimal precipitation, optimal rainfall. Various soil containing up to 4% of organic matter probably could meet crop sulfur requirements in lower yield conditions and insufficient rainfall. It's assumed that sulfur application to maize in this region may be limited to about 40 kilograms of the element per hectare. Let me continue with the next results from another field experiment. It was conducted also in Europe, in Lithuania, in cooperation with the Lithuanian Research Center for Agriculture and Forestry on sodipozoic soil. Sodipozoic soil had light texture, loamy sand texture, low content of organic matter, it's importantly to know, and soil pH was close to neutral. I would like to indicate good levels of available phosphorus due to the previous history of phosphate fertilizer application in optimal rates. Both dry, granular, and liquid phosphorus fertilizers were applied in this study. Importantly to indicate that phosphorus rate may be decreased by 18% without yield decrease. For example, with liquid ammonia polyphosphate, when we decreased phosphate rate up to 18%, in the second treatment, yield increased by 8 to 10% compared to a higher phosphorus rate coming from a dry fertilizer in the first treatment. So liquid fertilizer was more efficient in these conditions. Maintaining phosphorus rate when using liquid ammonium polyphosphate fertilizer and splitting phosphorus between broadcasting and foliar application in the first decade of May, in the third treatment, resulted to yield increase by 24-26% compared to the first treatment. where dry phosphorus fertilizer was applied in the same rate. Why did we obtain such interesting results? Actually, liquid ammonium polyphosphate fertilizer probably helped to decrease phosphorus fixation, while the soil having a close to neutral pH, thus increasing soil phosphorus availability to rapeseed plants. Soil phosphorus uptake by plant roots decreases under low temperatures in spring and the cold weather. That may be a case for the northern Europe, especially on podzolic soils, and split phosphorus application, soil plus foliar application in May, spring, seems to be a reasonable approach for sustainable crop production in these environment conditions, improving soil phosphorus uptake. Now I'm going to the next topic related to cadmium inputs to soils with phosphate fertilizers. It seems thus very important to apply low cadmium fertilizers to our soils. And this summary table for phosphate rock of various origin, sedimentary and igneous, shows that phosphate fertilizers produced by PhosAgro has the minimal cadmium content. You know, in the world, about 87% of mineral phosphate fertilizers are produced of sedimentary phosphate rock. And the sedimentary phosphate rock generally contains more heavy metals and metalloids than apatites of igneous origin. You know that approximately 30 metals and metalloids are potentially toxic to humans. The most toxic heavy metals for humans include lead, cadmium, arsenic. Although toxicity and the resulting threat to human health of any contaminant are a function of concentration, the chronic exposure to heavy metals and metalloids at relatively low levels can cause adverse effects. It seems very important to monitor the transfer of heavy metals and metalloids from soils to crops and, of course, to animals. With irrigation and excessive rainfall, cadmium, for example, may be leached to groundwaters. A series of field tests were performed in different regions across the world to validate the environmental efficiency of phosphate fertilizers produced by PhosAgro in terms of heavy metals inputs to soils. And these studies were developed to check the behavior of cadmium, arsenic, and chromium in the soil plant system. For example, 2-year studies in rice crop were conducted in Italy, nearby Milan city, on clay, comparatively young soil, with primary features of soil profile differentiation. And this study was conducted in a cooperation with the University of Milan. The initial content of pseudo-total cadmium and arsenic are shown in this slide, in the first table. Arsenic content was higher than the threshold level. This is related to the unfavorable environmental situation in the region where the experiments were conducted just near the industrial center. Heavy metals concentration in irrigation water at the point of its supply to paddy fields was also monitored in this study. Regarding fertilizer application, diammonium phosphate was a source of phosphorus. And importantly to note that rice grain yield increased on average by 45% due to optimal fertilizer application. In this study, soil had a high level of available potassium. That's why potassium was omitted. Our phosphorus containing fertilizer had no any impact on the concentration of heavy metals in grains, including cadmium and arsenic. And in the first experimental season, there was even a trend towards lower cadmium accumulation in rice grain harvested from fertilized plots, resulting from a considerable yield increase compared to the zero fertilizer control. In the central Russia, we cooperated with the Federal Research Center for Vegetables in Moscow region. Field experiment in cabbage, in white cabbage, was conducted on sodium soil. It had somewhat high content of available cadmium before the establishment of field experiment compared to the average content in soils of benchmark areas in Russia. Actually, field experiment was carried out under conditions of industrial pollution near the big city. Soil available arsenic was below the threshold level established in Russia. As you may realize from these results, the marketable yield of white cabbage increased by 27% due to the combined application of dry and liquid phosphorus-containing fertilizers and nitrogen, urea too. And the phosphorus application rate was as high as about 100 kilograms per hectare on oxide basis, P2O5. Mineral fertilizers, including phosphorus-containing fertilizers, when applied to the soil, and as foliar application did not affect the concentration of cadmium and arsenic in cabbage heads. Cadmium concentration in cabbage heads was at least 33% lower than the maximum allowable concentration in Russia. So cabbage that is safe for human consumption was produced on the soil having a high level of available cadmium due to minimum inputs of cadmium with phosphate fertilizers. Speaking about arsenic, this metalloid, its concentration in cabbage heads was much below the limit. Statistical analysis showed that the content of available forms of cadmium and arsenic in the soil did not significantly change when applying dry and liquid phosphate fertilizers compared to all the control treatment with zero fertilization. And the PhosAgro is the first Russian company certified to a national standard for products with improved characteristics, which introduced the world's most rigorous limits on heavy metals and metalloids. PhosAgro products are marked with a specific green one label, showing very low levels of heavy metals. Next, I would like to discuss the amelioration of alkali soils. Phosphate gypsum, a byproduct of phosphate fertilizer industry, is efficiently used to replace soil sodium with calcium. Thus, it's used to improve soil structure and to provide also sulfur, phosphorus, and micronutrients to plants. These field studies were conducted in a partnership with the Research Institute of Agricultural Chemistry on alluvial meadow, slightly saline soils, and drip irrigation in southern Russia. Root yield of carrot was increased by as much as 24% when the highest rate of phosphate gypsum was applied. That's all for soil amelioration with phosphate gypsum. And now I would like to speak about silicon containing products, silicon containing biostimulants. It's well recognized that silicon improves plant resistance to a variety of biotic and abiotic stresses. Water stress, temperature stress, salt stress are major abiotic stresses regulated by silicon. So silicon improves plant tolerance against climate-induced changes. Amorphous silicon dioxide, a byproduct of phosphate industry, is a very valuable product used for seed treatment and for foliar application. Monosilicic acid is the only form of silicon that can be directly absorbed and used by plants. It's interesting to indicate that the highest effect from foliar application of our silicon-containing product, Apasil, was revealed during a drought-affected season. Importantly to note that rapeseed did not generate any profit if silicon was not applied in a drought-affected season. Plant from Solanaceae family, like potato and tomato, respond to higher silicon rates compared, say, to grain crops, to oil crops. The optimal silicon rate for potato in these studies was up to 300 grams per hectare on oxide basis, CO2. So it's possible to apply much higher rates of our products to such crops as potato and tomato. In the last final chapter of my presentation, I would like to inform you about PhosAgro educational ecosystem. Nowadays, 24 educational centers across Russia have been opened by PhosAgro since 2019. And in Russia, we cooperate with 47 leading agricultural universities. Up to date, we recorded more than 400 video lectures, educational lectures, and an educational platform, ProAgro Lectorium, is an online service with free video lectures for extensionists, for farmers, and for students, first of all. 6 BRICS countries, including Russia, China, Egypt, Ethiopia, Brazil, and India, are actively participating in these educational activities. And at the moment, we have video lectures from 6 BRICS countries. That's all with my lecture. I would like to say thanks to all the participants for listening my presentation.
Thank you very much, Dr. Vladimir, for your informative presentations. So now we are going to do some questions and answer. If anyone having any questions to Dr. Vladimir, please raise your hands, or you can just pop up your question, please. While waiting for the others audience, I have my own questions, a couple questions.
Yes, please.
Regarding
Yes,
to
please.
your presentations. I'm not sure, you might already did mentions about this, but how can we use the ammonia polyphosphate fertilizer? We spray to the plants or to the soil, or we apply with the water into the plantations directly?
Thank you very much for your interesting question. Actually, ammonium polyphosphate fertilizer we produce, it's a liquid fertilizer. It's a liquid fertilizer, and it may be used for in-soil application, with sowing, with planting, for example. It may be sprayed on the soil surface before tillage, for example. It may be used during plant development in interrows, for example, in maize crop, in sorghum, interrow application, in soil application. Side dressing may be used in a liquid form on soil surface, for example, using sprayers. And I would like to mention also foliar application. Foliar fertilization with ammonium polyphosphate fertilizer may be also used and effectively used in crops. In our region, for example, it's very effective to include foliar application, especially during cold winter season with low temperatures, when phosphorus uptake is limited. And foliar fertilization, it's a good addition to basil application, to soil basil application.
And what is the mechanism for plant to uptake this form of fertilizer? They uptake through the roots or through the leaves directly if we apply as the foliage one.
You know that polyphosphates are hydrolyzed to monophosphates in soil solution, in water, and monophosphates may be taken by plant roots, by plant leaves. Yeah. It's a chain. Polyphosphates, it's a chain from monophosphates. And actually, some part of phosphorus in these fertilizers is presented in a monophosphate form, not polymerized, for example. Approximately 2/3 of phosphorus in polyphosphate form and 1/3 in monophosphate form. And the monophosphate form is immediately available, for example, when foliar applied fertilizer is practiced. But polyphosphates require some time in soil. That's why phosphorus fixation may be decreased. So how to say it, somewhat long-term effect. Because polyphosphates need about 2 weeks to be converted to monophosphate form in the soil solution. That's why this form of fertilizer may decrease phosphorus fixation and improve plant phosphorus uptake on calcareous soils under such environments.
That seems like more efficiency compared to applying as the granular one.
Yeah, more efficient form of phosphorus fertilizer on calcareous soils.
Thank you for addressing that questions. And I have one more questions for you. Because in Thailand we have lots of we have a big piece of land that contain salt salinities, saline soils. So you did mention about the phosphate gypsum. What condition that we can use that phosphate gypsum? Normally, gypsum in Thailand, we recommend people who has sodic soil to apply gypsum. So what condition for phosphate gypsum that can use in general? Is that possible for saline?
Right. Actually, in Russia, we apply phosphogypsum for soil amelioration, first of all, on sodic soils. Yes, exactly. Sodic alkali soils to replace soil sodium with calcium. But according to our field experiments, the phosphogypsum may be used in various soil conditions to improve soil structure because of good sulfur content in sulfate form. And sulfur in sulfate form also improves soil structure. And it was shown that phosphogypsum is a source of phosphorus in some extent. It's a good source of sulfur, and it's also a good source of micronutrients. So it's a kind of fertilizer, actually. Not only a soil improver, but it's a kind of fertilizer.
Okay, thank you very much. And we have two questions from the chat from Ms. Narukamon. How does PhosAgro perceive its role in addressing climate change within the agricultural sector, particularly comparison with other global fertilizer producers?
Answering this very important question, very actual question, speaking about climate change, I would like to cite research articles, meta-analysis related to phosphorus fertilizer application and climate change. And in a large number of research, it was demonstrated that optimal phosphorus fertilizer application improves soil carbon sequestration. Optimal fertilization with phosphorus increases soil carbon content. So phosphorus fertilization is very much important to decrease the negative effect from the climate change. And a big number of research was conducted on this topic.
Thank you very much. And another question, how does PhosAgro manage water-related risk in its production area under increasing climate variability?
We need to develop new technologies, new agricultural technologies to address climate changes. Of course, crop breeding, improving varieties and hybrids, it's one direction. But agricultural technology considerably affects crop resistance to drought conditions. For example, balanced nutrient management with nitrogen, phosphorus, and potassium micronutrients improves plant health and improves plant resistance to drought conditions. And silicon, it's also a part of modern technologies. A large number of research was conducted on silicon. It was well demonstrated that silicon application considerably improves plant tolerance to stress conditions, to drought conditions. And I think it's a good decision to include silicon-containing products into the technology and to improve crop resistance to changing climate. So I think nowadays it should be a part of modern agricultural technologies in drought-affected areas. It's a very good approach to improve crop resistance under such negative conditions, both nutrient management and silicon application.
Thank you very much. Is there anyone having more questions? Otherwise, I have one more question. Sorry.
Yes, please. Yes, please.
I'm sorry if no one having more questions. Do you have any innovations or technology for for reducing the acid in acid sulfate soil apart from agricultural lands? Normally in Thailand, we have promoting farmers to use agricultural lamps to fight with acid sulfate soil. But do you have any more efficient technologies or innovation that can help those farmers, at least helping them make it easier? Because sometimes using the lime is quite difficult. It's come as bulky, so they have to apply all over the area. So do you have any technologies or any thoughts of that?
Thank you for this very important questions related to acid soils. And of course, we agree that liming is very much important. We don't produce lime. But we have solutions how to improve plant tolerance to aluminium, to manganese, for example, on acid soils. And in this case, again, silicone application may be helpful. Because silicone improves plant resistance to toxic aluminum, to toxic manganese on acid soils. And it was a big number of research showing that silicone containing products may be helpful under such conditions.
Okay.
Of
Thank
course,
you
liming is required, liming plus silicone application.
Thank you very much. And I think we come to the last question from the chat box from Mr. Aska Khan. He's from Pakistan. How much carbon dioxide is generated during the whole process?
Thank you for such an interesting question from Pakistan. Actually, the topic of my today presentation was to report about nutrient management, not about carbon dioxide emission. It's a topic for separate lecture, for separate presentation, because I'm dealing more with nutrient management, but of course we have such calculations of carbon dioxide emission from the fertilizer production process. But it's a question of another presentation, I think. It's quite another topic. Very important, very actual, but it's a big topic to be addressed, speaking about carbon dioxide emission from the industry.
Thank you for addressing the questions. So I'm not sure if anyone having more questions, please feel free to put it in the chat box.
บัตรเดียวสักนิดหนึ่ง
ได้ค่ะ sorry. Dr.
Yes,
Pitayakon, please.
yes. Thank you for your presentation. I want to know your idea and your thinking about your product when it's used in Thailand, something like that. Thailand is a tropical country that is the temperature is so hot, the activity of microorganism in the soil is very active. What do you think on that if your product is used in this country? Thank you.
Thank you very much for your question. Our phosphate fertilizers are used in more than 100 countries through the world, including tropical conditions. And phosphorus is in a water-soluble form in our fertilizers. But phosphorus fixation is very high, and we are thinking how to improve phosphorus availability to plant roots. And now we develop new products with microorganisms, with helpful bacteria to improve phosphorus availability from phosphorus fertilizers. So we develop, our special department develops new products, so-called biomineral fertilizers. It's a new fertilizer with improved phosphorus availability.
Thank you ค่ะ Thank you ดร.มีอะไรเพิ่มเติมไหมคะ
ไม่มีแล้วครับ
ค่ะ Thank you very much. To let you know, Thailand, we are in the tropical country, right? And then we have I think around 25 million hectare of agricultural land, which is a half of the countryside. And then I cannot say we suffer from acid things, but like 60% of the 60% around almost 20 million hectare contain acid. in the soil. So we sometimes we find difficult to manage our soil in terms of improving the agricultures. And also we have the problem with the salt in the soil as well, saline soils, and they are the more problems in the soil, like, you know, we have erosions, we, apart from acidification, salinity, we have erosions, we experience the shallow soils, we experience droughts in some parts of the country, lots of things that influence our farmers and the way of we do our farmings, or the practice that we use in the country. So the fertilizer also one of our challenges as well. How can we manage its efficiency, and also how can we promote it in the right way to the farmer? It's kind of like difficult for us to tackle it as well. So, and thank you for your informative presentation today. We see kind of like very important topic that we need to consider, take into our accounts as well. And thank you, Dr. Vladimir, for your presentations again today. And thank you, everyone, for participating in this event. And we come to at the end of our session today. Before I say goodbye to everyone, including Dr. Vladimir as well, I would like to remind you that the next CESRA talk is going to take place in February 2026 at 1 p.m. We look forward to seeing you all next month, and thank you very much for participating in this event. Thank you, Dr. Vladimir, and seeing you again next time. Thank you very much.
Thank you. I highly appreciate the invitation. Thank you.
Thank you.